Well, happy Friday, everyone, and thank you for joining us today. We're talking putting the pieces together, software programming 101 for enthusiastic amateurs. So let's say you have an idea for a new app that's going to transform the marketplace and the world. Or maybe you just want to make an app that's fun, but you don't know anything about software programming. Well, don't worry. Through our conversation today, you'll learn that although computers and the internet seems unimaginably complex, under the hood, every app consists of some simple pieces. Now, we also will answer some questions like how computers store and manipulate data, the way software developers use simple pieces to build complex programs, and the challenges of debugging and why all software has bugs. But it's an interactive conversation, so we want to hear from you. So click on that QR code right there on your screen. Now, what industry do you work in? What problems are you aiming to solve? And what's your experience level like with programming? We all want you to answer some of those questions there. Now, this is being recorded and will be available at the same URL after our conversation today. So if you have to step out or anything, please go back and rewatch it. Or if you have a friend or anything that you think might be interested, please text them or send them the link, and we'll make sure to get that out there. But let's get to the reason we're all here. Professor James Grimmelman, he's a professor of digital and informational law at Cornell Tech and the law school. He helps lawyers and technologists understand one another, applying ideas from computer science to problems in law and vice versa. He studied how laws regulating software affect freedom, wealth, and power. But he's also written about search engines, social networks, hackers, and magical 3D printers, among other things. He's also just launched a new certificate program called Web App Development, and that link actually will be found right there in the chat as well. A link to that program, again, like I said, can be found in the chat where you can submit those questions as well, and we'll be fielding those questions kind of throughout our conversation today. But there you'll learn everything from writing programs to simple processing to how to use Python and even writing interactive web-based apps. Professor Grimmelman, thank you so much for joining us today, and happy Friday.
It's a pleasure to be here with you.
Cool. So I'll get to my first question. So how do computers work when we're talking about not just turning them on, but how it allows us to open programs and really store data? Let's baseline our conversation here.
So let's start at the very beginning with ones and zeros. If you hold up your hand, then that's a 0. Hold up your thumb, that's a 1. And congratulations, you are a 1-bit computer. You can store a 0 or a 1. Hold up your finger, the second finger, that can be either up or down. That's a 2nd bit. And you keep on going like this. And so your 10-bit computer and computers that we're using right now to talk to each other are just like that times millions and billions. And from that, you can make numbers, 0, 1, 2, 3, counting in binary. And from those numbers, you can store audio and video and letters. And with those letters, you can write words. And with words, you can write computer programs. So a computer program is just a special kind of data stored in a computer. And what makes it special is it's commands to the computer itself to run and do things.
Interesting. And, with that as a framework, how do we go from, just simple ones and zeros and letters and everything like that to the internet as we know it today?
So it's been a decades-long progress of growth. But once you have a computer that can run simple programs, you can use that to write more complicated apps. So you remember how Microsoft Word has gotten richer and more complicated over time, or how Facebook has added features. All of that is just taking a computer and adding more lines of code to do different things.
I do remember the very first Microsoft Word. It was a little rough. I've loved their upgrades ever since. Now, how do we go into the internet as we know it now, developing apps and everything like that?
So a program that you run on your computer, like Microsoft Word, that's a piece of software. It runs on your computer. It does things. It takes data on the computer and does things with it. And every computer on the internet is basically the same kind of thing. It's a computer. It has a processor and memory in it. It has commands. It takes data stored as electricity on that computer and modifies it in some way or another, follows its instructions to do things, changes data, sends data around from different places, transforms it. And the internet is just a whole bunch of computers connected by wires or by radios. So when you want to download something from a website, your computer puts together your request and takes your thing you want to look for and sends some bits out along a wire if you're plugged into a network in your home, or over a kind of radio network if you're using Wi-Fi or a wireless phone. And those bits go to a computer run by your telecommunications company. And from there, they go along other wires through their various telecommunications companies until they get to the server that you want to talk to. And those bits go to that computer, and that computer follows its instructions and processes it and sees what you want and returns a picture or a spreadsheet or a song or whatever you're looking for, and sends those back as bits over along the wires back to the various other computers, back till they get to yours. And your computer turns that into a display on your screen or reacts to it. It's just computers sending bits back and forth, talking to each other.
So when we're talking, say, a picture or a song, is that just kind of a bunch of ones and zeros? Is that kind of the concept?
Yeah, it's a bunch of ones and zeros, and your computer knows, take these ones and zeros and turn them into a picture. So let's break these up into little chunks, one chunk for each pixel on the screen. And that chunk tells it the red should be this bright, and the blue should be this bright, and the green should be that bright. And then the next chunk goes to the next pixel. It takes those ones and zeros and maps them into how bright every pixel on your screen is. And the amazing thing about computers now is it's so fast, it can get all of that data and update it 60 times a second. It's just incredible how fast they are.
I'm old enough to remember those original computers, and it was very, very slow to try to download some music. I for sure remember. Now, when we're talking about programming, one is programming hard, but two, when we develop apps, do you have to be a master programmer or master coder to develop even just a simple app?
So to develop a really simple app, you do not need deep expertise. So if you want to drive in the Formula One racing, you need to be a really good driver. You need years of training. You need top-notch skills. If you want to drive down to the store to pick up some groceries, you don't need extensive training. Anybody can do that part. And app development is the same way. There are teams of thousands of people who build world-class software. It's incredibly complex. It does amazing things. And there are people who work on their own and build things in their spare time. You can do it at any level, and people often start at one level and move to another over the course of their careers.
And switching gears a little bit now, I know your online certificate programming courses are designed to teach aspiring programmers and people who simply just kind of need to understand really kind of how these basic things work. So, what basic skills or proficiency levels should someone bring into class with them? Maybe, if they're just starting out or, taking one of your classes.
So this is really meant to be the very beginning on-ramp to your journey through technology. And so you really don't need to come in with anything. You need to how use your computer well enough to be watching this conversation right now. Because you can point your web browser at the eCornell website to watch us. You can point your web browser to the eCornell site that we teach the course in. Mm-hmm. And once you've got that, everything runs in your browser, and you can practice right there and develop your basic programs right there on servers that eCornell runs. And that's all you got. If you can connect to a website and log in, you have what it takes to get started down that path.
I think that's easy enough for us, especially working in this digital space with the pandemic and everything like that. So what are some key things that people will take away if they decide to sign up for the program?
So the courses start by logging into one of these eCornell servers and writing really simple programs. So we write basic programs in a language called Python. It's very friendly, very designed to hold your hand and lead you through things. But it's a powerful language that's used by lots of major companies. It's a really wonderful combination of easy to get started with and powerful to use. Mm-hmm. And we start by talking about how do you get a program to run? What is it that you do? You type text in a part of your screen, and then you hit a command, and the program does something. Mm-hmm. Just getting started with that. And then we gradually build up to do more complicated things. We store different kinds of data, like strings of text versus lists of numbers. And we learn how to do things like sort them or to correlate one source of data with another and to combine them in interesting ways. And from there, we build up to writing simple programs like chatbots and calculators and simple games, and just working with using Python to learn how to express your ideas and then to actually implement them as you write them. And from there, we take a tech tour of some very important modern technologies. So things like databases, APIs, and the web. We show you how to fit all of those into that foundation of programming in Python that we started with.
Mm-hmm. And we do have a surprise for the audience, but before we get to that surprise, I do want to ask, you obviously know what's coming up. Is there some key terminology that we should know before we give that audience the surprise there, or just key terminology that you teach throughout the program?
No, let's just jump right in.
Perfect. So the surprise for the audience, if you can guess, is we actually have an example. So James, I'll hand it over to you, and you can give us an example of what it's like taking the class.
Okay, so this is a sample of something that I like to do early on in my programming courses, and you will meet something like this in the eCornell certificate. And this is an example of how to write a program that interacts with a user and does some simple calculations. So in the US, you buy eggs by the carton, which is a dozen eggs. So suppose that you are trying to keep track of inventory for a dairy farm. Well, chickens don't lay eggs in dozens, they lay eggs. So you got a bunch of eggs and you're wondering how many cartons will these eggs fit in. So let's write a program to see how many cartons you need for a given number of eggs, and then how many eggs you're going to have left over. So this program should find out from the user how many eggs they need to sort out. So I'm going to write in here, find out how many eggs, and then we are going to compute the number of full cartons and leftover eggs. And after that, we need to report the totals back to the user. This is the first step of any programming task, is decide what you're going to do and break it down into manageable chunks. So in Python, the way to find out something from the user is to use a command called input. Want to get input from the user, use something called input. And that all commands work by having a pair of parentheses after it. And those parentheses tell it specifically how to work. So in Python, you ask for input by putting in quotes the thing you want to ask the user. How many eggs are there? So we're going to ask the user to type in how many eggs there are. And once we do that, we need to store that in something called a variable. We need to keep track of it. So I'll say total eggs equals. So I've got a variable called total eggs. I'm storing the data of how many eggs there are in something called total eggs. And what goes in there, we ask the user to input how many eggs there are. Now, one last thing I need to do here is the user is going to type in a bunch of keys on their keyboard. So they're going to type in 1, 0, 0, numbers. Those are digits. Those are characters that they type. We have to turn that into a number, the actual number 100. We use another command called int to convert that list of text into an integer. So now we got the number of eggs. So we need to compute the number of cartons. Number of cartons is going to be, well, it's the number of eggs. And we have to divide that by 12. And one of the subtleties of programming is there are different concepts. Because if I just type /12, and that user types in 13, then in Python, that's going to return 1 point and then 1/12 of a carton. It's going to give you the exact decimal number all the way out. That's not what we want. Cartons come in whole units. So we want to do division with rounding, which uses double slash. This is one of the things that makes programming difficult. You have to be super precise about what you want, because the computer will do what you tell it to, even if what you told it to do wasn't quite what you meant to ask it to do. So that's going to tell us how many cartons we've got. And then we need to figure out how many loose eggs there are after we're done. So I'll do loose eggs equals total eggs. And this time, we need to subtract out the number of eggs we just put in cartons. So we'll take total eggs minus times 12. So that's the number of eggs that are now sitting in cartons that aren't part of the total eggs we need to have left. That's the number of eggs that are loose. So once we've got those totals, we're going to tell the user how many there are. So I'll do print, which is Python's way of typing out text to the user. And I'm going to say there are, and then I'm going to use a plus sign. Now we're used to plus being addition. In Python, plus can also mean put two things together, put two strings together. So I'm going to say turn the number of cartons back into a string of text. That's going to print out to the user, there are 4 cartons, or there are 8 cartons. I'll put the letters, the word, cartons, and then we'll copy that, and we'll repeat the same thing for the loose eggs. And then we'll put periods in just so that we're typing out things that make sense to the user. And let's see if I got this right. So I'll type Python, which is how we run a program. And then I'll type the name of my program, which is eggs.py. How many eggs are there? Let's do 100. There are 8 cartons, and there are 4 loose eggs. It works. If there are 36 eggs, there are 3 cartons and no loose eggs. And that's writing a program in Python.
And how similar is this to, what you do in the program?
So when I'm programming in the course, it's like rehearsed and on the video. So you're not getting quite as much of the improvisational flavor, but it's basically the same thing. We do exercises like this in the certificate program. We build up programs to do things from simple parts. We talk about what those parts are. And we also talk about how to break a complex sounding task down into manageable chunks.
And is this really the kind of baseline for all programs and apps?
Yeah. Everything you see out there is built on this. It's just more of it. You learn more different commands. You write longer programs. You put them together in more complicated ways. But at the end of the day, everything is built from individual lines of code that look like this using small parts put together.
And I'm assuming the more complex the program or app, the more lines of code there are?
Yeah, so this is a 13-line program. There are programs out there that are 10, 20 million lines of code.
Wow.
It's more than I could write.
I could only imagine that program. I could only imagine. So let's talk a little bit about programming language. So what are some examples and what makes them different from each other?
So I'm using a programming language called Python for the course here. And one of the things that makes Python really nice is it's got simple expressions for printing out strings. So if I want to print out this is how many cartons there are, I can put this together using something that looks very straightforward. It's easy to read. It's very friendly to me to know how my program works. One other thing that Python has is I can just use a variable like total eggs or like cartons without any overhead. I just say, there's a thing called total eggs, and then we're going to stick the number of eggs the user typed in there. There are other languages that require you to say more about the variables. You'd have to say total eggs is an integer. Cartons is an integer. This other variable is a string. You'd have things called types, and you have to be very precise about keeping track of them. And it's a pain. It requires more work. But one of the things that happens when you do that is the programming language can keep track of what type things there are. And if you try to add a string and an integer together, it'll say, that doesn't make sense. These are different types. You've probably got a bug there. Why don't you go fix this before you're running it out in the real world and somebody gets hurt? So they can help you with avoiding bugs up front by structuring your code in the right way. And there are lots and lots of other languages that are specialized for different things. Python is pretty general purpose. You can use it, all kinds of settings. You can use it to glue databases and apps together. You can use it to write a fitness tracker. You can do all kinds of things. There are programming languages that are really specialized for displaying fancy graphical interfaces. There are programming languages that are specialized for running networks. There are programming languages for managing your printer drivers. There are programming languages for thousands of different kinds of tasks that are really closely adapted to particular domains.
And one thing I'm actually interested in is you mentioned before that, when you're writing these things, you have to be very, very precise. You can't be very general. I'd be interested to know, is there one piece where people struggle with the most? Is it being, very, very precise, or is it having that idea of you have to tell the program exactly what to do? Is there something that's very difficult for people when they're first starting out?
So I find, in my own experience with my students, the hardest part is getting a mental model of what's going on inside the computer. You look at something like this and you say, okay, the cartons is the number of total eggs divided by 12. And then you might think if the number of total eggs changed later, well, cartons will change along with it because they're in this relationship. This equation has to be true. And that's actually not quite how it works. When you get to line 7, it says cartons is the number of total eggs as of right now. And after that, these two variables go off along their merry way, and they might never interact again. And you have to make dozens of conceptual connections like that to say, this is the right way to think about it. This other way isn't quite right, and I want to think about it this way. So in the course, we try to do a lot with graphics and examples to say, think about it this way. Like a variable is like a box. It holds something. You can put something in, but once you put something else in, you have to take the old thing out of the box. There's not room for more than one thing at a time. And we try to help people come up with metaphors to conceptualize what's going on inside the computer.
Interesting. And now, how do we go from just one basic program or one basic app to the different ones connecting with each other? So I think of, signing into a program and it's like, hey, let's use your Facebook login. How do we get to that point?
So this is one of the really exciting things about the internet, the way in which these programs can connect to each other. And it's not just there are computers on the internet that connect to each other, but it really is programs interacting with each other. And a way that a lot of this stuff happens, and one of the things we cover in one of the later units in the program, is this idea of APIs. So API stands for Application Programming Interface. And it's basically a way that one program says, hey, if you want to work with me, here's how to do it. The program, instead of the interface on a screen or using a device, like the interface on your toaster has some knobs and a lever to pull down. Well, this is an interface meant to be used by programs. It says, if you want to use the features that I provide, like logging into a website through Facebook, connect to me, send me data formatted in a particular way, and I promise to send you data back formatted in a particular way that responds to what you want to do. And so lots of services on the internet have these APIs. Stripe has an API that you can use to process payments. Spotify has APIs for looking up information about different musicians and different songs. Wikipedia has an API for interacting with their web pages and getting information about what's in the different ones. And so what you learn to do is you learn to write programs that interact with an API that say, okay, there's an API out there. How do I make a request to it and get some data back that I want? And you also learn what's happening under the hood on the other side. When you are implementing an API for others to use, well, some data comes in this particular way. Here's how you unpack all of the pieces of it, look at them and see what the user wanted you to do. And then based upon that, you figure out what data you need to send back to them or what you need to update and how to respond to that request.
Interesting. We actually just got a question in from Hadassah. I apologize if I'm saying the name wrong. My apologies. But they asked, so you have to learn the language Python here first, right?
Yeah, Python is sort of the introduction, and it provides a nice glue for connecting to other concepts. Because I found that rather than trying to throw HTML and APIs and SQL databases at everybody and do a little bit of this, a little bit of that, the approach of our course is, well, let's connect everything to this core of Python that you already know. Mm-hmm. And that way you're building on familiar concepts rather than learning new ones for all the different kinds of programs that are out there.
Interesting. And as another quick follow-up, someone asked, how important are comments in a code? How often do programmers refer to these?
So the program would run just fine without comments. Here in line 1, when I say find how many eggs, that's a comment. The hashtag or pound sign at the start of the line tells Python, this isn't an instruction to the computer. This is a comment for other programmers or myself reading this, so I remember what's going on here. And the program will run just fine without comments. If I deleted all of these, it would still work. But the comments are really helpful for me to walk through the process of doing it. It's kind of like having a useful checklist right in the program editing window with me. They're useful to me if I come back a year from now and I'm like, how did this program work? Oh yeah, I remember. The comments jog my memory. And they're really useful for other programmers. If somebody else comes in and wants to add a feature to this program so that it also calculates how much milk goes in the quart bottles, well, then they've got comments to know the structure of this program, and they can pick it up more quickly, and they can make changes themselves. So comments aren't needed to make it work, but they're a really important part of software development.
Very cool. And I want to thank you two for those questions. I really appreciate it. And keep those questions coming. We'll be answering them throughout. One last audience question, and we'll get back to it. So Rose actually asked, is Python much simpler than L++, or rather C++, or rather C hashtag? What is the difference? Is one way more complex than the other, and do they work together?
Yeah, so Python and C and C# and C++ are fairly similar languages in the universe of computer languages. And if you've learned one of them, you'll find that the basic concepts of all of the others are now pretty familiar to you. And yes, Python is simpler and easier to work with than the C family languages. It puts fewer obstacles in your way, and it goes more out of its way to help you when you're writing programs. The philosophy of Python is there should be one obviously right way to do it. And there's often you can write really simple programs that are clearly doing the thing you want them to. C code can be harder to read. But C is really widely used. Languages in that family are important. They have a lot of great applications. There have been some really great advances in them over the years. I like to think of Python as a great foundation for learning C. Python is, in addition to being a widely used language, it's a good teaching language. C is a great language for doing things in. It's not a great teaching language.
So if you have kind of a basic understanding of one, does that kind of translate into the other? Is that kind of how it works?
Yeah. The two of them share a lot of the syntax. I'd write a little bit differently if I'm writing this program in C. I could probably translate it over to C or C# in a couple of minutes. Anybody who knows one will recognize the structure and a lot of the keywords in a program written in the other.
Mm-hmm. And I just want to switch gears a little bit. So what does kind of the career landscape look like right now for, people who are programmers, or, are they in high demand right now or in low demand? What's kind of the career potentials looking like?
So right now, tech continues to be in immense demand. That every tech company is looking for people to work there, and they are really there's an endless appetite for apps and services and people to develop them. And a lot of this is specialized. There are people they're only really looking for PHP developers, but you have to start somewhere. And having a foundation of knowing how apps and programming works is really essential to work with people who are programming. That every step of knowledge you've got along the way helps you work in these fields. Because they need people to do management, they need people to do debugging, they need people to do quality assurance and customer service, and being able to dive into the code helps immensely with every one of those jobs. And in fact, you often find that there are jobs that are 5 or 10% coding and 80% related stuff. And having a little bit of that makes you a lot more productive than having no foothold on it at all.
Okay, so there are some things where it's not 100% coding the entire time. There's other related things as well.
Yeah, I mean, so this certificate program came out of a course that we teach at Cornell Tech to MBAs and to law students. And these are groups that are by and large not going to go into full-time coding careers. But we felt that it was really important for them to have a foundation in it because they're working on project teams with people who are programming. And the collaborations are so much better when your lawyer who's working on a patent application or who's advising your startup knows some of the tech. Like it's an incredibly important edge for lawyers who are really working closely with tech companies. And the same goes for people in business and in other lines of work too. It's, if you're going to be working in a tech-based economy, you can work productively with so many more people when you have this baseline of knowledge.
And, now that we're on the career topic, I'm thinking, it just came to mind, how accurate are, movies in which we see, programming? One that comes to mind, I think now is Hackers with Angelina Jolie. Yes, I am that old. I think it was maybe mid 90s, late 90s, early 2000s. It's been a while since I've seen the movie. But anyway, how accurate are some, Hollywood films in regard to, programming and programming careers and things like that?
So generally, this is not a super realistic description of how programming works today. Now, absolutely, there are programmers and people in tech who will go off and they need to have several hours to concentrate and do something. It's a kind of very careful, precise work, and being able to hold it in your head without interruptions is part of it. So there is a kind of deep focus that a lot of programming involves. But it's a very social activity for any kind of significant development. One thing that's happened a lot in the last couple of decades is pair programming, where two people will sit at one computer and one of them will type while the other watches, and they talk to each other constantly over what they're doing. The person typing explains what they're trying to do, and the person who's watching will say, okay, maybe you should swap the order of those two lines because so-and-so. And it's designed to help them think through what they're doing so they all both have a better idea of how the code works. It's a very social activity. And practices are, you don't lone wolf in any kind of large organization. You have other programmers review your code, you talk about it with them, you'll discuss it with group teams. There's a lot of knowledge, and a lot of the work of software engineering consists in how do you get groups of programmers to work well together. And that's a very social activity.
I would actually really love to see that at some point. That's one thing I got to keep on my radar. I got to see that at some point. Seems really, really interesting. Staying on this topic, is there, a movie or a book or, maybe a documentary or anything that just kind of quickly comes to mind that gives kind of a real world example of kind of what it's like to work in the programming world?
So I give you two things that I think are really good. There's an article by Paul Ford that was basically the cover story in a large portion of an issue of Business Week from a couple of years ago, it's almost book length, but it is this really, really funny walk through what programming is like. And it's entertaining. It gives a really good sense for the flavor of modern software development and how programmers put different things together to make more complex programs. And the Business Week made a really cool website to go with it that provides visual examples, involves like actual little bits where you can reprogram parts of the article. It's a very clever demonstration of the work of software development.
That's interesting.
If you're looking for something a bit longer, Clive Thompson's book Coders is a really nice introduction, just a good portrait of some of the diversity of what people do when they're developing software.
Okay, interesting. And kind of staying on topic, I am interested in going a little bit of a different direction, but how have you seen, coding from when you first started to now? Have you seen, again, maybe more publicity, less publicity, as far as things being brought to light? What have you seen kind of throughout your career?
So I'll think about two things. One thing is that programming is much more popular and much more widely known now. Back when I was studying it, it was this thing, we'd go to the science center basement and hole up in there, in these labs, and there's like this small tribe. And now it's widespread. Everybody knows, something about what's involved. They know people who do it. They've seen it on movies and TV. They see tech companies being in the news. It's just much more widely known. Mm-hmm. The other thing that's really different now than it used to be is how much easier it is to work on it. I remember having to wrestle with computers just to get the basics of a programming environment set up and not really being sure what I was doing. And you save your work and then you sort of cross your fingers and pray. And now the tools are so much better. The demonstration I gave you, that's running in my web browser. This Codio platform that eCornell uses really does help you get to focus on your code. It takes a lot of the stupid surrounding setup stuff and hides it from you and provides you a platform where that's all taken care of. So that's so much more the case. You go back to the 60s, people wrote programs by putting them on punch cards. You tie your stack to the computer room and then it runs it. And if you get back, if you trip on your way and they fall over the floor, well, congratulations, there goes your afternoon, putting them all carefully back in order. We've come as far since the days of just typing in your program as just typing in your program was from punch cards.
Interesting. I never thought about it that way. I could only imagine. You just walked into the office carrying that huge stack. I could only imagine. I feel like I probably would be the one that would trip at some point. But I actually just got a really interesting question from one of our viewers. They actually asked, would things like coding video games would that be something that would require a lot of knowledge in coding?
So it depends on how sophisticated the game you want to make is. If you want to code a AAA Call of Duty, that's going to take a lot of sophistication. You're going up against huge teams that are the best in the business. But if you want to make a narrative adventure, you can do that with tools like Twine or Ink that are very much like the Python that we're writing. You're using them to write descriptions and interactions. If you want to make a 2D side-scroller or a top-down RPG, then there are tools you can use to put these together. You're going to need art assets as well as the text, and this certificate really focuses on the text part of programming, the logic of the interactions. But the core of the logic, if you bump into a monster, then deduct the number of hit points from the monster that corresponds to your current weapon strength. That's the kind of logic and event-driven architecture that we do talk about in the certificate program. So it provides, let's say, a foundation from which one could tackle game-specific programming tools and environments.
Interesting. I feel like I have played my fair share of Call of Duty in my day, for sure, back when I was in college. But what about like a program like, I'm thinking like Solitaire or Snake? Would that be something that wouldn't require a lot of code?
No. That we do a simple card game without the graphics in the certificate program. So we do actually do a little bit of, this is how you would write an interactive loop. It's not real time. That requires some skills that you would get into in a later course. But we do the basic idea of you get some user input, you have a computer player update the game state based upon that. So we get some of the core concepts out.
Interesting. And we just got another question from somebody. They asked, what are the necessary or good skills to have to be a good programmer? So what are some characteristics of a good programmer?
So I feel like you have to be detail-oriented when it comes to getting the parts of your program right. That the computer is extremely, extremely literal. It has no concept of what you meant, only exactly what you said. So if you make a typo, spell check in Microsoft Word might flag it for you. But in your typical programming language, that typo will cause your program not to work. So you need to go and find and fix it. And so a lot of your work is like taking a piece of code you've written that is 95% done and getting at that last 5% of the way by going over it very carefully to look for the spot that's causing it not to work and make sure you have all of those checks and cross-checks right. So there's a bunch of very detail-oriented work, and it takes some patience. And it requires a bit of open-mindedness about how things might be working. You have an idea of how you want it to work, and you need to be willing to accept for the moment that it's not currently working the way you'd like it to, and really try to put yourself in the place of this extremely, extremely literal helper. The computer really wants to help you out. It really wants to do what you want, but it has so little imagination. You have to project yourself into, okay, what is this line actually doing? Oh, I see. It's doing that thing, and I make this change, that it will fix it.
Interesting. Keep that in mind. And we actually just got a great question from Connor. He asked, can you share the names of the articles that you referenced again? Eric, can you repeat the name of the movie or the book or the realistic story program you were talking about before?
Yeah, so the article is by Paul Ford and was published in Business Week. And the book is by Clive Thompson, and it's called Coders.
Interesting. And what's one thing you took away from the book? Or the article, rather, either or.
So one of the things I really liked about the article is that he emphasizes how little programming takes place on a blank slate. Like the example we did just now where I said, let's write an egg sorting program. And we started literally with a blank screen that said, type your code here. That doesn't happen as much. What happens right now is that almost anything you want to do, people have written libraries that help you do a big part of it. So if you want to compute time conversions between one part of the world or another for your video conferencing app, then you should not sit down and try to write code to calculate how many hours time difference there is between you and the person you're talking to. There are good libraries people have already written that keep track of these conversions, that know about things like daylight savings time, that know about the half-hour time zones in some parts of the world. They have all of that taken care of. Your job as a programmer is, okay, I need to convert the caller's time to the recipient's time. So I need to connect my program to one of these existing libraries to do the conversion. And that's kind of like, being a plumber and okay, I've got this kind of pipe coming from the main feed and this kind of pipe going to the upstairs bathroom. What kind of joint do I need to get these there? And your job is to know the different kinds of pipes and know how to fit them together, much more than it is to build this complicated thing at one end or the other end from scratch.
And we actually just got another question from James. He asks, what's your favorite code checking app or website?
So I am going to say something that's not quite a code checker, but I'm a huge fan of something called pythontutor.com. And what I love about that one is you can put some Python code into it, and it gives you a visualization of what's going on. So rather than being based around text, like the example we just did, it shows you with arrows and boxes how the different data in your program fits together. And I find that really helpful. If I don't know why my code's not doing what I think it does, I can plug some of it in there, and I can see, visually, what it's doing compared to what I expected.
Interesting. And just switching gears really, really quick, going back to your certificate program, what's that one thing you can promise the folks who sign up for the program?
You'll have a bird's eye view of how things fit together. You'll connect programmers writing code by typing things into computers with databases that store lots of information, with APIs that do things on the web, with web pages and web-based apps. And you'll see how those things get glued together to actually make an app that does something useful. You'll be able to say, okay, I see this thing out there. It's like these things that I know, just with more details.
Interesting. That's good to know. And I guess with programming as a whole, with people who do sign up for the class, do you find that it's easier for, maybe the younger generation to pick up programming, or maybe the older generation to pick up programming? Do you see anything as far as, I'm just remembering, it took me literally months and months and months to teach my grandfather how to do simply just copy and paste from one document to another. Again, they didn't grow up with computers, but is it something that you find where it's easier for, a younger generation to pick up programming, or maybe an older generation to pick up programming, just given, the detail-orientedness of it? Do you find either or?
I have not really found an either or kind of thing. I have some students who are coming straight from other programs, other students who've been in practice or in work for a long time. And I don't find that the challenges they have really break down along any lines like that. I think a lot about computers can be really unintuitive to learn if you haven't been using them forever. Like if you have not been really doing stuff online, being forced to switch your banking from in-person to online, and going to communicating by email can be disorienting. But like I was saying earlier about programming tools being better, a lot of that has been made less of an obstacle today. So when it comes to this, it really is sort of like cookbook, just click here, click there, and now you type stuff in one window, click this button and see what happens. When you get to that point, the challenges people face are really individual. Some people say, oh yeah, I totally get data types and I see how this information is different stored in computers, but I don't see how the program gets from here down to there. I don't understand how it does one thing than another. Somebody else has the opposite experience. Oh yeah, of course it goes down here and it goes around the loop several times and goes down there. But can you explain how a string is different than a list? Now, for whatever reason, our brains find some things come naturally and some things come different. And I don't think there's any major habits of mind or experiences that obviously map onto where people have challenges.
And something interesting I just thought of is programming useful even if you don't have a career in it? Does it build any other useful skills even if you're not constantly coding all the time?
So, one skill that it builds is the ability to just look at a piece of tech and get a sense of what's going on behind it. Mm-hmm. When you're the same way that you learn how to turn the thing off and on again, you program for a while and you're like, okay, I bet this is a network problem rather than a problem on my computer. Or this keeps crashing, but I actually think it's because I did the other thing. You sort of get a sense for isolating where the problem could be. People who program for a while also say that it changes a bit about how they speak and think with natural language. That the precision you have to express ideas with in a program helps them be more precise when they're reading and writing. That you learn, when you're using or and to do logic inside a computer, it helps you notice when maybe and is ambiguous in the way you're using it to speak, and you would want to rephrase that sentence. So it helps with some clarity of expression. And I also think that the patience and detail-orientedness of programming is just a generally useful skill for written communication and for preparing reports and making things look right.
And so we got about 10 minutes left, so I want to continue to kind of field some questions, but our conversation is going really, really well. So let's kind of talk a little bit about you. I'd be interested to hear, would you be able to speak on some of the research you've done here at Cornell?
Yeah, so one thing that sort of connects pretty directly to programming is that I'm a law professor, and I work on technology law and sort of try to draw between computers and law. And one of the things I've been doing with some colleagues who are computer scientists is trying to formalize parts of law. Not all of it, we'll have judges who are robots. But there are areas where lawyers write really, really repetitive documents. You do thousands of documents that have the same basic format, but you have to vary the details a little bit because every client has a slightly different need. You get this a lot when people are writing wills or when businesses are signing purchase order contracts. And we're trying to use programming languages ideas to help lawyers be more precise. So again, the lawyers are still going to be there, but think of the lawyer as a kind of programmer doing legal programming. And then some of the pieces that they put together and the way that you interpret that, the parallel between computer language and legal language starts to seem pretty interesting. So that's a big area for me, which is exploring the kind of precision that lawyers use in their writing with the kind of precision that programmers use in their writing.
I'm just visualizing no judge there, kind of like a robot judge. I'm just visualizing that. It would be a very, very interesting concept for sure. And now, how have you seen that change over the years? Just, like you mentioned, say, a lawyer, writing a will. Do you find, how has that changed over the years, I guess?
So one of the things that I'm really excited about in the legal world is how there are companies and startups now that are taking things from software development and applying them to legal work. So it started with, lawyers would have big databases to keep track of all of the evidence in a case. Mm-hmm. But now there are really interesting tools, for example, version tracking. Programmers working in teams on a big piece of software have to keep track of all of the different code they're working on. Because if I'm working on one file and you're working on another, we need to both be able to make our changes and then make sure they didn't break each other. So we have to watch for the interaction. Well, lawyers working on deals will have the same kind of issues. And so there's been some very interesting products that take the really sophisticated tools programmers use to keep their work coordinated and to keep track of all of the revisions. So they say, oh, we need to go back to version 3.6 so that we can undo the hot patch for the printers. And then, well, lawyers might need to do that for clauses. So you're seeing them getting advantages from building tools that build on the similar tools that people in software development use.
And one thing that I'm actually be really interested in is how long would it take to make a new program or update a new program? So I'm thinking, maybe just kind of a basic iOS system for a Mac, for example. It seems like we get updates all the time. How often or how long would it take to just kind of update a system like that?
So it's not even how long, it's like how many people have to work on it. Like, in a sense, like Apple is going to ship a new update every year, and they'll put as much in that annual update as they can get done in that year.
Okay.
So it's not like, oh, iOS is completely rewritten every year. It's like they've got somebody in there who is working on making the search faster, and somebody else who's adding a new kind of emoji to messages. And every feature that they can get in that's tested and works well by the deadline will get put in the next release.
So we should continue to update our computers as often as we can.
Yeah.
Correct?
And I should actually say, like, when Apple tells you update your computer, you should do it. Like, they push out updates to close security holes that would let hackers steal personal information. Generally speaking, when the company that make your phone or Apple or Microsoft tells you to update iOS or Windows, do it. You are keeping yourself secure by doing that.
That's good. That's good to remember. And we get about 5 minutes left. I want to, of course, be always aware of your time. What is the one thing you're most excited about this certificate program?
I'm really excited about the idea that you actually end up with an app that runs on the web and does something. It's not fancy, doesn't have fancy pictures, but we finished the course building an interactive menu for a restaurant. And it lets you browse the menu by section, put new items on the menu, and every piece of that is built from parts that we've done during the certificate program. So the logic of it, the HTML for the web page interface they're doing it in, we did that. The database behind it is code that we wrote together during the program. All of the glue holding it together, we did all of that. You can see every piece of it running. It's like you've opened up a watch and you can see all the gears ticking around. And I think it's really amazing to have that sense of, okay, I know what all of these parts are. I actually know what I'm looking at here.
That's so interesting. That's so interesting. I'm thinking of like going to a restaurant down here on the Commons. I don't know how often you've been up to Ithaca, but like right down on the Commons, it's like everybody has the QR code where you can scan and pull up the menu on your phone and everything. My mind just flashing back to that. But James, thank you so much. And I want to leave our audience with just kind of one thing. If there was, one thing you could reach out to the audience and kind of let them know or kind of, sway them to want to take the certificate program, what's that one piece of nugget or that one piece of information that you would want them to have when making their decision?
I think the animating philosophy for the course is that not everybody is a professional programmer, but everybody ought to know a little programming.
Mm-hmm. Interesting. Well, James, thank you so much. I appreciate you being here. Audience, thank you again so much. We appreciate all your questions. Sorry if we weren't able to get to all of them. But again, this is being recorded. So if you missed it or you had to step out, please feel free to go back and rewatch it. And if you have a friend who might be interested, please feel free to tweet that out or send that or email that link to them. The video should be up here in a little bit. Thank you, Professor Grimmelman, so much. Thank you. Have a happy Friday. And audience, have a good Friday as well. And we'll see you later.
It's been great. Thank you all for the great questions.
Thank you.